just kicked off. Thermal switch just kicked off. That was about, I don't know, I'll have to double check, but I think about 7 minutes in. Just kicked off. We got 103 internal temperature. On the inside of the aluminum 2x2 12-gram Umrex cylinder. That should start coming down now. It should probably take about, last time it took about 3 to 4 minutes for it to cool down and then kick back on. We'll see how long that takes. Thermal switch is already down to 72 Fahrenheit. The heating elements without power off. That's 72. So it's cooling off quickly too, because again, these little grid heaters here, being that they're applied directly to an aluminum cylinder, that aluminum is acting like a heat sink, so it's efficiently drawing away the heat and bringing it internal to where the CO2 cartridges are. So thank you, Umrex, for coming out with a aluminum 2x 12-gram cylinder. If it wasn't for that, I would not even have had the idea to use it as a means of applying a heater or a CO2 warmer. Again, the whole point is not to have necessarily, heat the CO2 up, in 30 seconds. Oh, just kicked back on. All right. Oop, there it is. Sorry, my camera skills leave much to be desired. But you could hear the click. It just clicked back on. So the thermal switch is working better now that I found a polarity miswire between the two heater grids that I just fixed. Now both of these heater grids are actually wired the correct DC polarity. I suspect that was creating an issue where they were both warming up, but one was working better than the other. Let's put it that way. So I discovered that when I was testing for voltage. One of them was showing a negative and the other one a positive, so I fixed that now. And I'm noticing that this heater is definitely working better than it was. All right, back up to 104. And again, that's with this meat thermometer, whatever you want to call it, probe. It's just in there, touching the top inside approximately where the heat's coming from, coming through the aluminum housing. So again, this is open, obviously, so there is some cooling effects. I would think it would work even faster once it's closed up. Yeah. So let's see what the next heat cycle brings, since we're videoing this anyways. And let me check what the thermal switch is doing. Well, the thermal switch terminals are showing about 101. So it's getting pretty close to 104 again, 104 Fahrenheit or 40 degrees Celsius. I'm expecting this to cycle again. Cycle open to open the heating circuit again here. All right. Oh, it just did. Huh. Didn't hear the click that time. Unless it was the same time I was pressing the button on this laser. But yeah, the heating light is out. All we have left is the 12-volt green power LED. Let me wake this thermometer back up. Still showing 104 degrees in there. Sorry, my creaky wood floor. I should have put the Bluetooth on because it does have noise cancellation. Sorry about that. This is some crude testing going on here, guys. And yes, this is all on the fly design that I thought up. No schematics exist yet other than that of which is in my head. At some point I'll put it to paper once I finalize or I'm satisfied with the design. This is in its infancy right now, so yeah, I know guys are excited, so a lot of people are excited about this possibility and they're asking a lot of questions, but this is very much in its infancy. And bear in mind, I'm using cheap, inexpensive parts, components to build this. I'm not using high quality stuff. I mean, I'm using Amazon stuff. We all know what we all know what that means. We all know where it comes from. So there's that. So in some ways I'm fighting components, what's the best component to use, and the only way I know really is by testing. That's the only thing I can do is start somewhere if it makes sense to me, and I don't get it right all the time. Absolutely I don't get it right all the time. It is what it is, just having fun experimenting, and oh, there it goes. So she kicked back on again. What's that, 8 minutes now? So she's cycled, what, 2-3 times? I'll have to play this video back to see. 2-3 times in the short time this video has been going, 8.5 minutes or so. That's an improvement from previous tests. So I think that miswire I had with the polarity of the two heating grids, not having them on the same DC polarity, was definitely causing a situation where the grids weren't working as efficient. The bottom grid was not warming up very much, which is the one that I had the negative polarity on, whereas the top grid over here, this one had the positive polarity, and it was functioning much better. Matter of fact, right now it's hot as hell. But the bottom one, I could hold my finger there and I'd just feel a little bit of temperature. I'd put the laser on it and it would say maybe 80 degrees, So now the top one, while the heating circuit's on, it's, anywhere about 135 is the peak at the max that it's catching. Bounces around a little bit, probably because I can't hold it steady. And again, this is another Amazon product that's in my hand right here. I can just imagine what the accuracies, the hysteria is on this particular device. It's probably like plus or minus, who the heck knows. Anyways, let's see what the terminals, that thermal switch was saying here. Let's see what we can get. All right, I got the laser right on the terminal of the thermal switch. Yeah, we're coming back up. 190. 107.8 over here now. See, my whole point of having that thermal switch was really as a safety measure, because I didn't want the internal temperature exceeding much over 120 degrees Fahrenheit. All the information I could find online about CO2, if you leave a CO2 in the car and it's 120 degrees in the car, you know, these things can get as high as, quote, 1500 PSI. So I'm thinking about that, and I'm like, all right, so I don't know when they're gonna cook off. You know, I don't know when it becomes an issue. Of course, it's still inside this aluminum housing, so I also not looking for 1500 PSI. I don't think I want to put that through the Pastelli, even if it is available. So I'm kind of, just kicked off again. So there's another cycle. Okay, that's off. And now temperature's coming down. She's dropping pretty fast. See, that's another thing that, you know, having this up against this aluminum cylinder, again, the whole idea of it being a heat sink, it's drawing that heat away fast. Right over here we got, what we got down here? 104. All right, so now it's basically in a maintenance mode, where I would imagine, you know, what I'm gonna see is it's gonna start cycling a little quicker. We're about 12 and a half minutes into this test. We started off where, you know, ambient temperature here was about 70, 72. Yeah, I like to keep it warm in the house. In fact, right now, if you look at this, we're actually warmer than that now, so there is some heat. All right, if I look at the table, 73, right, over here, 73, 74, so it is pretty warm in here. I get the heat blowing right now. So, all right, I think this is a much better test, and again, I discovered a DC polarity miswire that I had. You know, it's really easy to do that when you're putting in more than one of these little grid heaters. Not to mention, they don't give you color-coded wiring. They're both red wires, and really it doesn't come into play until you try to parallel them. And now I get the correct polarity. So, and obviously it's working much better. I am psyched with this right now. Oh, she shut off again. All right, that's enough cycles for now. I'm gonna end this quick little test. And I did resolve my puncture issue. It was those Crossman CO2s. Putting a spacer in between the two seems to help a bunch. It's not perfect. I still gotta play around with that, but the rest of the test, though, I think I'm going to use Umrix cartridges just to make sure that, you know, I know this Umrix probably designed it around their own cartridges, so this cylinder. Anyways, I rambled on long enough, guys. Thank you for your feedback as always, and just, you know, keep in mind this is just this is a work in progress here. Thank you.